righty, students, we are now going to calculate our descriptive statistics of the angular velocity. So I'm going to go to data here, and we're going to go to data analysis, descriptive statistics. And before I do all of that, I need to cancel all of this. Notice we have our formula here. And so we just need to eliminate the formula right now. And so I'm going to do that by copying and then just pasting special. And I just want the values there. So we have our values, and we are going to wrap the text. So now that we have this, I want to go ahead and find the normal distribution of the angular velocity. All right. So just going to go ahead and say equals to NORM dot DST. And then our X, again, is going to be the angular velocity. And then we have our mean. I can't do this yet. So I haven't found the statistics yet, guys. So I'll go ahead and put the statistics here. I thought I chose. Well, okay, I just missed it. All right, so data analysis, descriptive statistics. I'm going to go ahead and select this angular velocity and label this in first row. And let me see, where do I want to, okay, I want to put that here. And then we have summary statistics and confidence level for mean. So that's going to come up in just a second. All right. Excellent. So now we can find the normal distribution. All right, so the X is going to be our angular velocity, and then we have our mean here. See how it says mean? We're finding our mean, and I'm just going to get the function key 4, comma, and then we need our standard div. So our standard div is here. And again, I am going to hit the function key F4, comma, false. All right, and so I'll just go ahead and double click, and all the way down, we have our information. Now I want to say something about this number. This is e to the negative 118. No. And this, no, I'm not going to do any one of these. So I'm going to go ahead and get rid of both of these points. So I'm going to delete, I'm just going to pull that up. And let's see if we have any more crazy looking points, probabilities. So I'm just going straight down. I'm basically looking at this column here. Oh, went a little too far, but see this? E to the negative 23? Nope. And I guess, where would that come from? Okay, yeah, there we go. And make sure no formula. Okay, there we go. So it was a remnant. So what I'll do now is I'm going to go ahead and take M and N, and I want to go to Insert, and I'm going to select on my scatter, smooth lines. So it's taking a moment. It's a lot of points. There we go. And so with this, I am going to change a few things. The first thing that I want to do is I'm just going to select on the graph. So I am going to select both M and N, and I want to my computer is acting up. M and N, and what I want to do is sort from smallest to largest. And you'll see that we have this plot here. We have some other outlier out here. It's weird. I'm going to leave this like that, but you guys go ahead and get rid of that outlier. It's not really likely to happen. So it's probably the very last number here. So what I'm going to do is I'm going to go ahead and say, all right, this is what I'm ultimately looking for, and we need to label our graphs. So I am going to definitely do that. And I kind of have the pulse width modulation is 400 microseconds. So I'll just copy that, and I'll use this as at a pulse width modulation of 400 microseconds. So I would rather, I'm going to leave it like that. I want to say with a raw count, but I'm just going to leave that as raw count 50. And I guess I can just go ahead and push this down. So that's the title. And the x-axis is going to be primary horizontal. This one is our angular velocity. This is going to be in rads per second. And then for our y-axis, we're going to have our vertical axis. This is going to be the normal distribution. All right, no units. So this is, to me, well labeled, and this is what I'm expecting you all to do, label well. And in the next video, I'm going to expound upon this a wee bit. I won't go through this again. I'm expecting you guys to do it for 50, 60, 70, 80, and 90.